Yeah, thank you, ma'am. So we just start with the session. I see very few participants have joined, maybe 8 plus 2, 10, 11. So is this head count is sufficient for us to start, Priyanka, ma'am? Or like we should wait? Oh, okay, fine. So as Priyanka ma'am like explained, like introduced my like I have done my Bachelor of Engineering in Instrumentation and Control Engineering. Okay, then I started working as an automation field engineer. Then many things I have learned in together for electrical engineering, then instrumentation, then electronics, lot of things. And then the today's session's topic is like ETAP, right? So who has heard this ETAP software or ETAP technology? Can you raise your hand or maybe unmute yourself and like introduce yourself? Anyone? So everyone is from electrical engineering background or what? Maybe. Okay, great. Your good name? Okay, Priyanka ma'am only. Okay, fine. So others, maybe you can unmute yourself and speak something. If you have not used, maybe you can unmute and say, "Ki we have not used. This is the first time we are hearing this software's name and all." So that will go into deeper and deeper. Okay, fine. So basically, I'll just give an introduction to ETAP. What it is? Okay. Okay. So ETAP, Electrical Transient Analyzer Program, is the full form of ETAP, is a software program or platform that will help you or any engineer to design, operate, and maintain electrical systems. Okay. Actually, I'm traveling, so maybe I'll not be able to present anything, but maybe I can make this session very interactive. Okay. Yeah. Um, yeah, and it maintains electrical systems. Okay, it is basically used in many industries, including power generation, transmission, and distribution platform. Okay, so basically it includes. Um, okay, who have heard digital twin technology? Anyone? Digital twin?
No, sir.
No. Okay, fine. Suppose you have any electrical system and you want to create one digital model of that particular electrical system, then that is called as digital twin. So this is by definition. Now, can you explain or elaborate with an example? What other things we can like create a digital twin? Any example from participants? What is Industry 2.0? Okay, fine. Any other practical example? Okay. For example, there is one industry and you want to do all power calculations of that industry. So it includes maybe all your electrical system, including your diesel generator to whatever resistance, okay, inductance, hardwares are there. Okay, so that includes everything. So all this power calculation you have to do somewhere, right? So hello.
Yes, sir.
Okay. So all this power calculation you have to do somewhere, right? So that somewhere maybe it will be a piece of hardware or any digital platform. So when we call digital platform, it will be like Excel or any software. So in Excel, maybe we can write down each and every electrical instrument or electrical equipment and its specifications. Okay, and we do have to do some algorithms, have to apply some formulae into an Excel, or else we can have one software which will calculate every single calculation of power related things. So whatever our agenda is, okay, so this is good that if we use any software platform, right, which will give you readily all calculations, all SCADA things, all graphical user interfaces, how it looks like and all. Okay, you can like insert any electrical equipment in between and do these calculations in one go. So that software platform, one of software platform is ETAP. Okay, ETAP. As we discussed, ETAP full form is, yes, ETAP full form,
Electrical transient and analysis program.
analyzer program. Okay, then I'll ask few basic questions then. Electrical transient, what it is? What is transient? See, this is first introductory session wherein.
Sudden change in the magnitude of alternating quantities, that is the transient.
Okay, okay,
Severe changes in the magnitude of alternating quantities.
okay, great. Any other participant want to express? Okay, fine. So as we discussed, first feature or application, we can create a digital twin, we can create any digital model of an electrical system. So yes, maybe we'll give you some homework or assignments, which will help you to advance or excel in this particular technology. Okay, so digital twin is one of assignment which we should do, okay, together. So what it is, how it is made, what different technologies are involved in digital twin. See, one of basic thing is power calculation. Okay, for which we are using this ETAP. See, our agenda of this session should not be learning only ETAP. Along with ETAB, what different technologies are there which we can incorporate to have as an electrical expert? Okay, so that we can incorporate in industry or maybe in colleges or in any platform wherever it is required. Okay, so yeah. Then second thing, as it is like in name itself, it do analysis. Okay, so since it is good analyzer, so it is used for analysis purpose as well. So it performs analysis like load flow, short circuit, and transient stability. Okay, so these are the main things for which it is mainly used. Okay, analysis purpose. Then third thing, designing phase. So in designing, many electrical engineers are deployed in industry or work as a consultant for designing any electrical systems. So what it is involved, it includes your power calculation, it includes designing of all electrical equipments, placement of that electrical equipments, then sequence of this electrical equipments, then power calculation of these electrical instruments. Then what? So specification wise, you have to choose the things like you have to filter according to your applications. What specification that electrical equipment should have, must have. Okay. So yes. Apart from this, anything else in design phase? Yes. Anyone? Please unmute yourself and you can interact. Maybe not with me, but with everyone. Okay, fine. So next is simulation purpose. So next application or feature is simulation. So it analyzes electrical power system dynamics and transients. So anyone have used any simulation platform like MATLAB, LabVIEW, or any platform for simulating anything? MATLAB. Okay, then. Okay, MATLAB. MATLAB is used by one of participant, right? So can you please tell us like what application you have used or utilized MATLAB? Okay, okay, fine. So along with MATLAB, there are many other tools which are available in market. Okay, so one of tool is like we use in virtual instrumentation platform is LabVIEW. Okay. LabWave is basically virtual instrumentation platform. Anyone know this technology? It's basically graphical programming environment. Anyone? Correct. Correct. So that is used for simulating anything. Anything means anything. Like you can interface any hardware in the world with any protocol. Okay. So along with ETAP, you should learn LabWave as well. Along with LabWave, you should learn C. Basic like traditional approach for an electrical engineer will be first thing we will learn PLC, programmable logic controller. Okay, so that may be एक Allen Bradley या Siemens सीख लो आप as a fresher कहीं पे तो join हो जाओ and then you'll start your career. So this will be approach for electrical engineers. Okay, and now the world is changing very fast, the technologies are changing very fast, and in industry is asking for very dynamic personalities, okay, having a vast experience in various fields, not only one thing you should focus. Okay, so we'll discuss many technologies, many environment, many platforms over here. Okay, and yes, so what we discussed is simulation. Okay, so for simulation, along with ETAP, we should learn other technologies as well for simulating anything like MATLAB, LabVIEW, etc. Okay. Then fifth thing is monitoring. Okay, it monitors electrical control system in real time. Okay, what is real time? So instantaneously. मतलब कुछ तो हो रहा है और आप वहाँ पे मॉनिटर कर रहे हो इन रियल टाइम विदाउट एनी डिले. Okay, without any delay of a second as well. Okay, Yes, monitoring purpose. Then next is optimization. So you can optimize your system, your electrical system with implementing a right electrical equipment at right place. Okay, in a right sequence. Okay, so that will be like used or maybe help you for optimization of system. The next is predictive simulation. So it will predict future system behavior. How? You can induce any fault, any other specified equipments in between and see and analyze how it behaves basically. Okay, so yes. Now, these are the basic features of ETAP. Okay, uh, why we should learn this ETAP, that maybe we should know, right? Means applications of ETAP we should know, that will motivate to learn these things, right? So first application is arc flash. It basically analyzes arc flash. Okay. Anybody have installed this ETAP software in the systems? Anyone? Okay, so I'll request go to ETAP website, and maybe you can download that ETAP software. Okay, and maybe evaluation copy you can download and install it. Okay, and see how the environment is, like what different components we can introduce into the system, how we can design the system. Okay, that might help you. For designing perspective, maybe implementing your thesis perspective, yeah, any industrial application perspective. Okay, fine. So yes, second thing is cable system. It basically analyzes your cable system, like we discussed, any industry you want to establish, like from raw you're developing one industrial application. Okay, so how many equipments it will be there, what power factor it will consume, and all power calculation you're doing in this ETAP software. So how your cable system should be laid out, so that cable system designing or analysis part you can do in this software or technology or platform. Okay, then third most thing is renewable energy. So it analyzes your renewable energy systems. Okay, so if we have solar systems in your premises, okay, and you can do all power calculations according to your solar system input feeder you're getting into your design. Okay, so it will give you all calculations readily available in your system. Okay, fourth thing is DC system. It basically analyzes your DC systems. Then power management. It manages your power systems. Then load management. It manages all your loads. Then distribution management. It manages distribution systems. Okay. Then outage management. It manages all your outage systems. Okay. So yes. Anyone has any doubts? Please raise your hand. Okay. Good. Okay. Fine. Next, we have ETAP environment, then load flow analysis, then short circuit analysis, then arc flash studies, then transient stability analysis, how to do that, then harmonic analysis, then motor acceleration analysis, ground grid systems, how it is developed, then cable pulling system, how it is designed. Okay, then underground raceway systems, like cable ampacity, cable, underground, how underground raceway systems are designed and the stuff. Then protective device coordination. Okay. So then protection schemes, what protection schemes are available, how to design that protection schemes, like what is bus bar differential protection, what is transformer differential protection, what is motor protection, what is directional overcurrent protection, over and under voltage protection, then over and under frequency protection, then reverse power protection, then distance relay protection, how to introduce distance relays and all. Okay. Then we'll have an introduction to revision and wizard toolbar. Then DC power systems, how to design this DC power system. Okay, DC load flow and all, DC short circuit and arc flash, then battery sizing calculation, how it does. Then in renewables we should have like photovoltaic system, what it is, how to design these photovoltaic systems. Then what is wind power, how this wind power calculation is done into ETAP. Okay. Then maybe advanced things like advanced power system studies, like how to optimize your power flow, what is unbalanced load flow. Okay, how to what is optimal capacitor placement, then switching sequence management, then contingency analysis. Okay, this we should have an introduction, or we should learn these things. Then we should learn like DC control systems, what it is, how to design, how to DC control wiring systems. Okay. Then maybe in advanced things, practical projects as well for transient stability. So this should be like the things. Okay. So I would urge to install or go through this ETAP website and install this software. Maybe it will give you a glance idea how it is and what different textures are there, what different implementations are there. Okay. Maybe there are few series of videos are also available at ETAP website as well. And if you have Udemy access, then maybe I'll forward one or two courses to have an introduction or advanced studies in ETAP software. Okay. This is basically just an introduction to as a part of FDP or for students. So maybe we'll not go into a deeper things, but if anyone is interested, maybe it will be like very helpful, or maybe I can give you deep material, course material for if anybody is wishing to learn anything in deep. Okay, so no issues. So yeah, fine. um Okay, I see 14 members are there. Like, can we have an introduction from you as well, like what you're doing, so that maybe we can, diversify the contents of mine? Yes. So we'll start with this electrical thing. Electrical engineering, who it is? Yeah, Deepali ma'am, can you introduce yourself, please? So anyone, please, in sequence, we'll introduce ourselves so that it would help us to, get agenda very
Good
clear.
afternoon, sir.
Yeah.
Good afternoon, sir. My name is Deepali Roshan Lokre from Electrical Department. I am working as an assistant professor in Sanjeevan College of Institute and Technology.
Okay. Sanjeevani Kolhapur, right?
I have almost 5 years experience. Yes, Kolhapur, Panhala.
Yes, Panara, right, correct. I was there for face-to-face FDP, maybe in 2013 or 14, 2014 to 2016,
Okay,
maybe. Yes, yes, yes. I was there. Yeah.
okay.
Okay, great.
Hello,
Uh,
sir.
yeah, hi.
My name is Suraj Gaikwad, sir.
Yeah.
I'm working as head of the department.
Okay, great.
I have 10 years of experience in teaching.
Okay, good.
Yes,
From
my main
electrical
interest is.
engineering only?
Huh?
From electrical engineering only, right?
Yes. I am the head of the department of electrical engineering department
Okay, great.
of BTech. My
Great,
area
great.
of interest is power system.
Power systems, okay, great.
Yes.
Next. Okay, great. Others, maybe you can unmute and like introduce yourself.
Good afternoon, sir, and all.
Yeah, good afternoon.
Myself Sanjuni Murari. I'm a assistant professor in Navi Mumbai, Kharghar.
Okay, Khargar.
Yeah, Navi Mumbai. I have
Okay,
18 years experience in electrical department. My specialization is electrical power system, sir.
okay, great.
Thank you, sir. Thank you.
Okay, any other member is left?
Good afternoon, sir. My name is Sudarshan Chavan. Actually, I'm serving in Indian Army. I was instructor at Military College of Telecommunication Engineering in Mahu for 5 years. I
Okay,
am good friend of Mr. Amit Awad, which was in the college, sir. So he suggested me that actually we plan our communication systems and design power systems also for that. So that's why I'm attending this course
okay, great.
to just study and what type of new technologies are available for us to plan and execute our needs in Indian Army telecommunication systems.
Okay, good. Any other member wants to introduce? Okay, fine. So, yeah, our today's topic again is ETAP. Yeah. Uh, yeah, so ETAP is basically a very powerful software which is basically designed to perform simulations, then analysis and design of power systems. Okay. ETAP has very vast capabilities such as load flow analysis, arc flash. See, these are the key terms we are using in a session like arc flash. So we'll search what is arc flash. Anyway, we will cover an introduction, but not in detail. But maybe अगर टाइम मिलता है तो मे बी विल कवर इन डिटेल बट मे बी विल हैव वन consecutive session like advanced intermediate level of session whoever are interested. Okay, yes. So arc flash, then protection coordination studies, then cable pooling, then cable ampacity study, and then yes. So basically, this course is specifically designed to cover all the functionality of ETAP software. Industries nowadays are in pursuit of candidates having skills in power systems simulation packages. Having the knowledge to simulate power systems in ETAP can help students to procure positions in the power sector. Okay, so if anybody is interested to switch from college to industry, maybe this is a starting trigger for to start with the things. Okay. So first is ETAP, what is like mentioned in our 5 days program. Second is virtual instrumentation platform. Okay, for that maybe LabVIF and MATLAB. Yes, so these two technologies you should target for. Okay, even if LabVIF is not mentioned in our curriculum, this 5 days curriculum, I'll just introduce you with the technology or platform because it is like niche skill nowadays in market. Okay, so 5 years का बंदा है वो 15 लाख पैकेज मांगता है और उसको मिलता है. ठीक है, so this is a fact. This is a fact. MATLAB, yes, common technology है, but MATLAB में if you like do any specific things, if you develop any specific things like renewable energy or oil and gas related things, so these are the niche things. Okay, this we should target for basically. Okay, along with ETAP, MATLAB, and LabVIF. Okay, so these are the virtual instrumentation platform. So if you're from electrical background, maybe don't worry. Instrumentation and electronics things also we should know. Okay, we must know actually. Okay, because see, even if we have done our electrical engineering, that is specifically um, hardware thing. Okay, but still we are using or we are learning software platform as well. Okay, then why not to learn uh, design and development of softwares? Yes, we should, like industry 4.0. Okay, data analytics, data science, python must. Okay, so start learning python. Okay, python का basics तो पता होना चाहिए आपको. Yes. So now, this course also covers all the fundamentals of conducting analysis in power systems. Thus, it will be easy for beginners to follow the course. Okay, each lesson is basically tailor mode. Okay, to be detailed in and precise with practical examples. Okay, we should like correlate all your theory knowledge or whatever keywords, jargons we hear in these sessions, like arc flash we are hearing first time. Okay, no issue. Even ETAP we are learning for, we are hearing it first time. Okay, no issues. Okay, we should go and start um, finding practical examples of these keywords or jargons. Okay, jargon words. Yes. Now yes, probably no. Okay, fine. No issues. Can anybody explain what is modeling and simulation? We'll make this session very interactive, please. Sorry, you're not audible. Hello. Yeah, what is modeling and simulation? I have asked.
Hello, sir. Modeling
Yes.
means just construct that or create that circuit, and
Okay.
simulation means by using some software we can run that circuit visually.
Okay, great. And see what the results are, right? What is final result
Yeah.
and what are intermediate results. So if we are not getting any result, then maybe we can change components. We can change intermediate electrical components. Okay, and we'll try to achieve the benchmarks or whatever specifications are written to have in our design, right? So basically, modeling and simulation is the use of models. Okay, models, maybe it will be physical model, mathematical model, behavior model, or any logical representation of system. Okay, and yeah, as a basis for simulations to develop data utilized for managerial and technical yes. In the computer application modeling and simulation, a computer is used to build a mathematical model which contains key parameters of the physical model. The mathematical model represents the physical model in words, and conditions are applied that set up the experiment of the interest. The simulation starts, that is, the computer calculates the result of those conditions on the mathematical model and outputs results in the format that is either machine or human readable, depending upon the implementation. Correct? Yes or no?
Yes,
So
sir.
the use of modeling and simulation within all your engineering is well recognized. Simulation technology belongs to the tool set of engineers of all application domain and has been included in the body of knowledge of engineering management. Okay, so modeling and simulation helps to reduce costs, increase the quality of products and systems, and document and archive lessons learned because the results of a simulation are only as good as the underlying models or engineers or operators and analyzed must pay particular attention to its construction. Okay, to ensure that the result of the simulations are applicable to the real world, the user must understand the assumptions, conceptualizations, and constraints of its implementation. See, basically, if there are few interlocks in your system, then we should implement that interlock. If we have some emergencies in your system, then we should have that emergencies to be implemented in your system. Okay, so all these calculations and mathematical modeling will cover all your design aspects into your implementation. Okay. Yes. So additionally, models may be updated and improved using results of actual experiments. Means, for example, if you are designing something, you are implementing, you are simulating that particular system which you have designed. If your results are not matching, you'll modify it, right? You'll alter your modification simulations, you alter your logic, your alter your algorithms, correct? Yes or no?
Yes, sir.
So, modeling simulation is a discipline on its own. Its many applications domains often lead to assumptions that modeling and simulation is a pure application. This is not the case and need to be recognized by engineering management in the application of modeling. Okay, so the use of such mathematical models and simulations avoids actual experimentation, which can be costly and time consuming. If, for example, if you don't have any hardware, okay, and hardware procurement will happen after a year or after 2 years, so before that we should be ready with our design, we should be ready with our simulations, we should be be ready with our results, calculations, analysis part? Yes. So for that, maybe there is like only simulation part, or without any integration, like hardware integration, we should only simulate and analyze the designed system. That is in our hand only. Uh, maybe if you are getting um, like the things, if any doubts, maybe you can raise your hand or maybe interrupt in between, and maybe we can brainstorm that particular topic. Okay. So since I mentioned this is just an introduction, okay, so actual intermediate or advanced thing will start subsequently. Okay. Yes. So now, for example, to determine which type of spoiler would improve traction the most while designing a racing car, okay, a computer simulation of the car could be used to estimate the effect of different spoilers shapes on the coefficient of friction in a turn, correct? So कार डिजाइन करनी है आपको, उसका स्पॉइलर डिजाइन करना है, स्पॉइलर का स्पेसिफिकेशन जो है, which type of spoiler would improve traction the most while designing a racing car. Okay, तो स्पॉइलर डिजाइन करना है तो you'll apply many like type of spoilers, and maybe you can calculate what traction it is giving you a result as a result. Okay, so yes, so your expectations, your benchmark, if that is not meeting, then you'll change specifications of that particular spoiler. Okay, so you'll change shape, you'll change material, you'll change angle, different angles, you'll change frictional things. Okay, you'll change many aesthetic changes. Okay, so this is at design level what you have done, but after implementing it on a real car, it is not giving a calculated result or expected result. Then you have to change the material, you have to change the shape, you have to change everything, which will give you or improve your performance of your spoiler of your racing car. Okay, fine. So this is next step to your designing. Like you have designed a spoiler, you are simulating a spoiler, you are simulating spoilers and analyzing your spoiler results with the expectations, with the specification, with the benchmarks. Okay, you should get, and if it is not matching, you're modifying your spoiler specifications, you're modifying your spoiler design. Okay, yes. So in addition, simulation can support experimentation that occurs totally in software. अभी मैंने बताया आपको वर्चुअल इंस्ट्रूमेंटेशन प्लेटफॉर्म है लैबवेव, उसमें क्या कर सकते हैं? यस, वी कैन डू a lot things in LabWave platform. Okay, so power for power systems, yes, whatever things are not done in other platforms, like interfacing perspective, interfacing to third party hardwares, embedded hardwares, we can very easily connect to these platforms. Okay, like we can develop a SCADA system. SCADA full form, anyone?
Supervisory control and attacks acquisition.
Perfect, perfect. Okay. Anybody can tell me what different options or technologies available in market for developing this SCADA system? Yes, LabWave is one of the technology which we can use for SCADA. Then second, ETAP is one technology. Then third, Allen Bradley. Fourth, Siemens. Fifth, Mitsubishi. Yes. So these are the Wonderware. So these are the basically SCADA platforms available in market which we should have. At least introduction तो चाहिए. ये SCADA है available. ये market में use हो रहा है. Okay. See, basically for 10 years experience, 15 years experience, you should get at least 4 to 5 lakhs per month salary in when you join any industry. Okay. So for that, industry needs should meet, right? मतलब इंडस्ट्री को जो चाहिए वो तो सीखो पहले. Okay. Now, uh, fine. So we discussed about modeling and simulations. Okay. Then, yeah, power systems. Yeah. So what is power engineering? It is also called as power system engineering, right? Which is basically a subfield of you can say electrical engineering. Okay. So which deals with the generation, transmission, and distribution and utilization of electrical power and the electrical apparatus connected to such systems. Although much of the field is connected with the problems of three-phase AC power, the standard for large scale power transmission and distribution across the modern world, a significant fraction of the field is concerned with the conversion between AC and DC power and the development of specialized power systems such as those used in aircraft and electrical railway networks. Right? So, power engineering draws the majority of theoretical base from electrical engineering and mechanical engineering. Why mechanical engineering? Yes. Array, turbo alternator, for example, if I want to design turbo alternator as an electrical engineering, all electrical calculations I can do. But to design turbo alternator in a mechanical form, mechanical engineer will be required. That's why this mechatronics branch is alive, right? So mechatronics or instrumentation people are there to support end-to-end result, right? Yes or no?
Yes, sir.
Okay. Then we discussed about this digital twin things. So what it is? Digital twin is a digital model of an intended or actual real world physics product or system or process, a physical twin that serves as a digital counterpart of the process, such as simulation, integration, or maybe you can call as testing or monitoring or maintenance. Okay, a digital twin is a set of adaptive models. Okay, that emulate the behavior of physical system in a virtual platform, virtual system, getting real-time data to update itself along with the life cycle, right? So the digital twin replicates the physical system to predict failures and opportunities for changing, to prescribe real-time actions for optimizing or mitigating unexpected events, observing and evaluating the operating profile systems. Though the concepts originally originated earlier, maybe originally originated from NASA, in an attempt to improve the physical model of simulation of spacecraft in 2010, right? So digital twins are the result of continual improvement in modeling and engineering. So this technology also you focus, okay, as a part of electrical engineer, as a part of power systems expert. Okay, you should focus on designing or learning this digital twin models, what it is, how to design it, what different aspects we should cater while designing. Okay. Yes. Fine. Now, um, in 2010s and 20s, manufacturing industries began moving beyond digital product definition to extending the digital twin concept to the entire manufacturing process. Doing as allows a business visualization to be extended to domains such as inventory management, including lean manufacturing, machinery crash avoidance, tooling design, troubleshooting, maintaining, preventing maintenance. Okay, so these are the things wherein we can use this digital twins platform. Okay, so digital twinning therefore allows extended reality. Okay, and maybe spatial computing to be applied not just to the product itself, but also to all of the business processes that contribute towards its production. Okay, so yes, सी ये डिजिटल ट्विन जो है वो किसने इंट्रोड्यूस किया, नासा ने इंट्रोड्यूस किया, कब किया, 1960s में किया, राइट, लाइक अपोलो मिशन करके था. ओके, so that Apollo mission, Apollo program, it is basically was known as a Apollo. Okay, hello, anybody wants to express anything, like someone has unmuted and trying to say something. Yes. Okay, fine. So NASA used simulators to evaluate the failure of Apollo 13 oxygen tanks, basically. Okay, so there this originally digital twin concept was introduced. Okay, so you can read about this digital twin and how it is introduced as a digital twin, and what different applications we can do with digital twin and all. Okay, so it is basically modeling and simulation mein, it is king. Okay, which is widely used in variety of industries nowadays. Okay, so basically this digital twin consists of three parts mainly. Okay, the physical object or process and its physical environment. Okay, the digital representation of the object or process, and the communication channel between the physical and virtual representations. Okay, so the connection between the physical version and digital version includes your information flows and the data that includes your physical sensor flows between the physical and virtual objects and environments. Okay, so the communication connection is referred to as digital thread. Okay. Um, Next, what we can uh, digital twin is related, uh, yet distinct concept to digital engineering, basically. Okay. Then maybe anyone knows the system dynamics? System dynamics concept, maybe. Okay, so basically, it is an approach to understanding the nonlinear behavior of complex systems. Okay, so okay, so anyone, can you explain, right, like what is power system simulation or electrical power system simulation? Yes. Anyone? Okay, from one part to another part, a waveform, flow. So these keywords maybe are useful. Anyone?
It involves the modeling of power generation equipment,
Okay,
planning, integration,
okay, great.
uh, of power plant onto electric grids and all.
Correct. So, for example, a short circuit study or fault analysis calculation करना है आपको, right? So, the short circuit current that would flow at various points of interest in the system use study for short circuits between phases or from energized wires to ground that you have to study, right? सो अगर
Yes,
मुझे शॉर्ट सर्किट करंट ही नहीं पता है कहाँ पे जनरेट हो रहा है तो how I can design my protective system, right? Right.
yes, sir.
Correct. So protective relays and fuses कहाँ पे apply करना है मुझे that I should analyze, I should study, I should calculate, I should do all calculations. Okay. Yes. So transient or dynamic stability studies show the effect of events such as sudden load changes, short circuits, or any accidental disconnection of load on the synchronization of the generators in the system. अभी for example phase change होता है, right? So phase change होता है तो synchronization mechanism comes into picture. So how that synchronization is done, okay, frequency and voltage, how it is synchronized, that everything theoretically at least you should know while calculating your system analysis, while designing, like not designing, post designing simulation things, maybe you can identify for better results, right? So next is like harmonic or power quality studies show the effect of nonlinear loads such as lighting on the waveform of the power systems and allow recommendation to be made to mitigate severe distortion. Okay, so that maybe we can do. Then लोड फ्लो कैलकुलेशन कैसे होता है? ओके, सो किसी को पता है लोड फ्लो कैलकुलेशन? So it is basically most common thing, right? In network analysis tool. Network analysis tool कौन से है? That maybe is your assignment for today's session. Okay. So it is basically for examining the undisturbed or disturbed network within the scope of operational and strategic planning. Okay. So using network topology like रिंग नेटवर्क है और कौन सा नेटवर्क है आपका, ठीक है? So transmission line parameters or transformer parameters or generator location and limits and load location and compensation. The load flow calculation can provide voltage magnitudes and angles for all nodes and loading of the network components, right? Such as cables and transformers. Okay, cables and transformer specifications you can have through this load calculation, load flow calculations. Okay, so yes, then maybe like what is short circuit analysis? Short circuit का analysis करना है मुझे, तो what it is? Like it is the power flow after a fault occurs in a power network, right? The faults may be three-phase short circuit, or maybe one phase grounded, or two phase short circuit, or maybe two phase grounded, or one phase break, or two phase break, or complex, any complex faults involved, right? So these are the basic things you can understand, you should understand for short circuit analysis. ठीक है, शॉर्ट सर्किट कब होता है यही पता नहीं है, बट उसका एनालिसिस करने बैठे क्या पता चलेगा, कुछ नहीं. तो बेसिक्स पता होने चाहिए, राइट? So results of such analysis, like short circuit analysis, may help you to determine what is magnitude of the fault current, what is circuit breaker capacity, rise in voltage in a single line due to ground fault, then residual voltage or and relay settings, then maybe interference due to power line. Okay, so these are the few things which you can analyze after your analysis is done. Okay, then maybe next is transient stability simulation. So what it is? See, this is very important concept. Huh? Transient stability simulation. Okay, so basic goal is what for this power systems is to analyze the stability of power systems from sub-second to several tens of seconds. Okay, so stability is this aspect is the ability of the system to quickly return to a stable operating conditions after being exposed to a disturbance, such as for example maybe a tree falling over an overhead line, resulting in the automated disconnection of the line by its protection system. मतलब एक झाड़ है, वो गिर गया, किस पे गिर गया? यस, ओवरहेड लाइन है, उस, उस पे गिर गया. क्या कर सकते हैं? कुछ नहीं कर सकते. So it basically results in what? Automatic disconnection of line. ठीक है, अभी प्रोटेक्शन सिस्टम भी क्या करेगा? झाड़ गिर गया, कुछ नहीं करेगा. आपके सिमुलेशन में झाड़ भी सिमुलेट करेंगे? नहीं कर सकते, राइट? So there are few natural calamities which maybe we should consider in simulation as emergency. Correct? In engineering terms, a power system is deemed stable if the substation voltage levels and rotational speeds of motors and generators return to their normal values in a quick and continuous manner. Okay, fine. So अभी इसका मॉडल डेवलप करना है आपको. तो मॉडल डेवलप करने के लिए क्या करेंगे? बेसिकली इनपुट्स क्या क्या होंगे इसके लिए? Anybody from audience part, please. ट्रांजिएंट स्टेबिलिटी सिमुलेशन, उसका हमें अगर मॉडल डेवलप करना है तो क्या क्या इनपुट लगेंगे आपको? अरे वो जनरेटर का स्पेसिफिकेशन लगेगा, नंबर ऑफ जनरेटर, साइज ऑफ जनरेटर, टाइप ऑफ जनरेटर लगेगा आपको. ठीक है, with any available mechanical or electrical or control parameters like governor है, उसका voltage regulation है, etc. right? Then आपको क्या लगेगा? उस पे लोड कितना है, each बस पे लोड कितना है. So a mix of residential, commercial and industrial load at each bus, वो लगेगा आपको as an input. Next, location and specifications for distributed control devices such as tap changing transformers, switch shunt compensation, static variable compensators, okay, flexible AC transmission system. ठीक है, अदना फनाना, ये सब कुछ लगेगा आपको, राइट? क्या है, कितने हैं, उसका लोकेशन क्या है, स्पेसिफिकेशन क्या है. Then what you'll require? Location and specification for protection devices such as relays and load shedding. ठीक है. बाद में क्या लगेगा आपको? लोकेशन एंड स्पेसिफिकेशन ऑफ एनी अदर रिलेवेंट कंट्रोल और प्रोटेक्शन डिवाइसेस. करेक्ट. सो ये सारे ये चीजें जो है वो एज एन इनपुट लगेगा आपको, किस लिए? मॉडल डेवलप करने लगी इसका ट्रांजिएंट स्टेबिलिटी सिमुलेशन के लिए. ओके. यस. देन आपको असाइनमेंट में पढ़ना है व्हाट इज यूनिट कमिटमेंट. यूनिट कमिटमेंट क्या होता है? तो सही, ठीक है. सो बेसिकली इट इन्वॉल्व्स फाइंडिंग द लीस्ट कॉस्ट डिस्पैच ऑफ अवेलेबल जनरेशन रिसोर्सेज टू मीट द इलेक्ट्रिकल लोड. उसमें फिर न्यूक्लियर आता है, थर्मल आता है, रिन्यूएबल आता है. ठीक है, जनरेटिंग रिसोर्सेज में. बाद में आपको पढ़ना है ऑप्टिमल पावर फ्लो क्या होता है. नेक्स्ट आपको पढ़ना है मॉडल्स ऑफ कॉम्पिटिटिव बिहेवियर क्या होता है. देन लॉन्ग टर्म ऑप्टिमाइजेशन क्या होता है. ठीक है. देन पावर सिस्टम सिमुलेशन के लिए कौन से सॉफ्टवेयर्स लगते हैं या फिर अवेलेबल है. ठीक है. सो दैट यू नीड टू स्टडी. ओके, फाइन. सो फाइन. As a theoretical part, maybe we have discussed, or theoretical is also always boring, right? Okay, fine. So maybe Priyanka ma'am, like can you continue like other things? Can you continue other things on behalf of? Fine. So we have almost completed the theoretical things. Maybe practically, or maybe along with the ETAP software. Maybe we can introduce other stuff as well to the candidates. Okay, like what is LabVIEW, what is Siemens platform, what is Allen Bradley platform, what different like Wonderware SCADA kya hota hai. So everything will have an introduction so that anybody is interested in future, maybe we can have some intermediate level session as well. Okay, na? Maybe if anybody has any doubt, maybe our session timing is 3 to 5, but maybe we should. Unfortunately, I'm traveling to some non-avoidable situation. Okay, so maybe we can cover maybe tomorrow and after tomorrow a little bit in detail. Okay, if anybody has any doubts, maybe we can cover it quickly, or else we can pause for now and resume tomorrow afternoon.
Hello, good evening, all of you. I am Professor B.N. Randeve, and I would like to thank our speaker, Mr. Amit Amrutkar, for sharing their knowledge and experience with us regarding it, theoretical part of ETAP. Your presentation were enlightening and appreciate the time and effort you back to prepare and deliver them. Thank you for sharing this information. It will be extremely helpful for our purpose. I would like to thank all the participants for their active participation and engagement throughout the FDP. Once again, I would like to thank everyone involved in making this FDP as success. Thank all of you, and we look forward to tomorrow's session. And so I declare today's session is concluded. Thank you.